Hello everyone, welcome to Empty Minds. As part of this video, we'll actually look at the Kubernetes. For this, there are three main prerequisites. One is the kube server version should be 1.13 and above, and the etcd must be version 3 and above. And to encrypt a custom resource, your cluster must be running Kubernetes 1.26 and above. So let's look at the problem statement. The problem statement is you can see the secret data in a plain text format within the cluster. So there are multiple ways of actually seeing this secret data in the cluster. Let's go through some of the methods now. So to do that, what I'll do is, in the first method is like by logging into masternode. And for doing that, let me log into masternode, and then for this we'll need a etcd client tool. So what I'll do is I'll install the etcd client tool as part of it, and this is the repository. And then what I'm doing is now I'm trying to extract it, and then once it's downloaded, let me extract this and then copy this to our bin directory. All right, cool. So now once we have done that, what I want to do is I want to actually come back and then also do some cleanup. So I'll just do some cleanups, and then let's take a look at what is the client version which we have. So at the time of recording, I had the etcd client version 3.4.23 and the API version is 3.4. All right, so now that we have this in place, now what we need to do is we need to create a secret. So for creating secret, what I'll do is I'll actually use the default namespace for doing this for testing purpose. So what I'm doing here is I'm just creating a generic secret and then saying key as secure key and then data as secure data. All right, so I'm actually creating the secret so that the secret is created now. And now what we need to do is we need to just execute this in the client and in the master node to see what's really happening. So what I'm going to do is I'm just going to execute this by doing a xdump, and you can see that. So let me expand this a bit. So you can see that the data that's there is being actually shown in a plain text format. So you can see that the secure key that I actually created earlier, and then the secure data that we have here is also being shown. So this is one way of doing this, and the other way of actually doing it is by logging into etcd pod itself and then executing the same thing instead of doing it from the master. So now let's have a look at the method 2. That is, what I'll do is I'll make sure that I'm actually logged into Kube. So sorry, I'm kind of used to OpenShift, so this is already logged in. And then what I want to do now is use the same secret that's already created, and then I want to actually make sure that I'm executing these things from a kube server. So let's have a look at what are the different pods that we have. So you can see that we already have an etcd pod named as etcd master, k it is lab dev. So I will actually log into this particular pod and then start executing the commands somewhat similar to that ones which we did earlier. So this is the command. So as part of this, I'm actually executing this command and I'm saying that use the etcd client and then use the certificates and the keys required for it. And then this is the endpoint to actually go and talk to it, which is the local one. And then try to get the my secret, which I created in the default namespace. So let's have a look at it. So you can see that now the secret is generated. And as part of it, you can still see that the data is secure data and the secure key has been shown in plain text format. And this is the second method. The other method is by actually accessing the physical path inside the etcd DB itself. And to do that, you have to be logged into the master node. And since I'm already logged into the master node, all I have to do is do a sudo -i so that I'm root, and then I'm going to navigate into the etcd path, which is this, and then I'm actually going to do the cat of the DB. And you can see that if I actually search for my secret, you will see that in the secrets default, my secret object has the secure key and the secure data as part of it. So this kind of shows that there are multiple ways of actually accessing the secret data that's been saved inside cluster. And the purpose of the video is to show how easy it is to actually get the data out of the cluster and also securing it. So now let's take a look at how to secure it. Okay, let's look at the solution. The solution is to actually use the encryption configuration, which is server-side encryption. And for this, what I'll do is I'll actually use the AES CPS technique as part of this demo. For this, what I need is to make sure that I create a key. So let me generate a key for this, which is a 32-bit random key. And then let me copy this key, which can be used later on. And then I need to actually log into the master node, and I've already done that on the bottom of the screen. And what I need to do now is to make sure that I create a folder inside Kubernetes for hosting my encryption configuration. So I've created a folder called as ENC, and then I'll actually place a file called as ENC config and then I'll put in the data based on the key that we generated earlier. So you need to be very careful with the structure of this YAML. And as part of this, what we're doing is we're actually saying that the provider is AES CBC, and the key here is secret. The key is key 1, and then we can see that there was a typo with the thing, and the secret is below this, and we have an identity. So we have this as a configuration, YAML configuration. Let me save this. So once I've done that, what I need to do is let me go to this folder just to make sure that this is under root, and then I need to make sure that I actually edit the Kube API manifest file, which is located at this. And then here, all I need to do is add in a configuration which actually says that we need to pick up the encryption provider, which we have saved in a specific location. So this is what we need to provide. We have to say that encryption provider configuration and the path of the configuration file. Once this is done, because this is like ENC is a folder which is not part of any of the ports, we need to mount them. So for doing that, I need to first create the, let me create the volume mount. And the volume mount is ENC, and I'll name this as ENC again. Once the volume mount is there, let me now add in the volumes. Okay, so the volume, I want to name it as again ENC, and then the path is ENC. All right, this is all we need. And before doing that, let's make sure our servers are still up and running. You can see that it's running. And once I actually do a save, and you can see that if I try to get a node, it will actually say it's not available. Just give it a minute or two, because what it's trying to do is it's trying to do a refresh. So let me say I'll come back after a minute or two. Okay, looks like the node is back now. So after we got the node, this means that the changes that we have actually added has been successfully reflecting. Now to test it, what we need to do is now we need to actually, let's create a new secret. Okay, so for doing that, what I'll do is I'll create a new secret in the master node. I'll exit this, and then okay, so you can say this, I'm actually creating my secret 2 with secure key 123 and secure data 123. Okay, so after creating this in the default namespace again, let me see how the data is stored in the etcd. So if you use the same command, and instead of actually giving my secret 1, I'm actually giving my secret 2, which is the one which I just created. And let's see what happens. And you can see that the data is completely encrypted. Okay, so let me use the same command and try giving my secret. Okay, and here when I actually use the my secret, you can see that I still have the old secret, which was secure key and secure data, which is still unencrypted. What it means is once we actually apply this, any secrets that's created then after is all encrypted, but any secrets that's already present in the cluster still retains as is with the same state. And if you want to re-encrypt all of them, what you can do is you can actually use this command, which is getting the secret and then replacing the same secrets, which is nothing but recreating them basically so that the API gets triggered for encryption. And now let's have a look at the same my secret. And you can see that the same secret which was unsecure earlier, or which was in a plain text, is now in a secured format. And that's it for this video. Thanks for watching.